Hello everyone. The common question in our mechanical technical interview we are getting, that is this is one of the common interview question, that is what is finite element analysis, or what is we are calling as a FEA, and then how it is useful in mechanical design. Okay, so this is a common question we are getting in the technical interview. So the answer here, we have to give in two parts. First, we have to explain what is a FEA, and then we can go for the what are the useful things, okay, for the FEA into the mechanical design. So first, if we want to explain the FEA, the answer is FEA. The long form is the finite element analysis. Okay. So here in the FEA involves a breaking down a complex physical structure into a smaller, simpler parts called finite elements. Okay, means here what is happening here, three things. One, we have a physical structure or physical parts. So that physical part we are breaking into the smaller portions or elements, we are calling that. Then these elements or this portion we are interconnecting at a points. That points we are calling as the nodes, and that physical behavior of each node or each connected element is mathematically modeled. Okay, with the and the system of equations representing the entire structure. So here three stages are happening. First, you have an object, right? This is an object. For example, we have a 3D design. Okay, 3D design, CAD design we created for the any part. Okay, so if I want to do the FEA on this part, I'm breaking this part into the small element or smaller elements or small portions. Okay, so that is what we are calling it the element. So here you can see the same part or same 3D part we are breaking into the three elements. Okay, and then we need to interconnect these three models or three elements using the uh, elements, means you can use the line or the different shapes are there, so you can interconnect them. That we are calling as the nodes. Okay, so you can see here these elements are interconnected. You can see this element to this, again this, then this, right, and then this. So you can see this is the connection is happening. Okay, so this we are calling as the nodes. So we have to explain this into the three portions. First, it is we have a some smaller object or we have a physical model. Okay, that physical model we are breaking into the elements, different elements, small portions, and that small portion again we are connecting with the nodes. Okay, and then this connection of the nodes or connected nodes, we are checking their displacement. Okay, and from this displacement, how much displacement, means if I'm applying the specific load, so how much displacement of these things nodes are happening. According to that, we can calculate the stress and strain onto the that particular object. Okay, so like this simply you can explain the FEA first. Okay, then the uses of the FEA into the mechanical design. So FEA we are using first for the structural analysis, definitely. So FEA is widely used to analyze stress, strain, and deformation in components. If I'm applying the specific load, okay, so how much deformation into components are happening, how much stress, how much strain, right? So this helps ensure that part can withstand the loads they will encounter during operation without failing or deforming excessively. Okay, so on this part, if I'm applying the specific load, so using the FEA, okay, you can see these lines. So these lines are interconnected, that we are calling as the nodes. From that we can understand from the displacement how much stress, strain, right, or deformation happening into this particular object. Then second is the thermal analysis. So engineers use FEA to study heat transfer within a components or assembly. That is also one of the for heat transfer to check, to study. This analysis helps in designing products that need efficient thermal management, such as engines, electronics, and heat exchangers. Okay, so this is also one of the use of the FEA that we are using for the to study the heat transfer, where the such parts like engine, electronics, and heat exchangers. Okay, And this is also one of the analysis. Main analysis is to analyze the failure analysis. Okay, so FEA help identify potential failure points by simulating worst case scenarios. Means if I'm making one part into the design, okay, so that needs to be checked virtually. We are validating, that we are calling as a validation method, right? So in the validation in the CAE we are analyzing this, or we can use FEA softwares, or in the FEA we can analyze this and we can simulate that part, and we can understand the worst case scenario, what are the failure points, and this analysis adds to improving the design and enhancing the product safety and reliability. Okay, so these are the three main use case, we can say, like structure analysis to analyze the stress, strain and deformation in components, then thermal analysis to study the heat transfer within a component, the failure analysis also to ensure the safety of the product and reliability. Okay, so you can simply answer this question. First, answer the FEA. What is FEA? Objects, element, nodes. Remember the three things and then use this, like the structure analysis, thermal analysis, and failure analysis. Okay, this is one of the important question from the CE point of view and from the technical interview point of view also.